Welcome to the solutions to the Regents Physics Kinematics problem set numbers 16 and 17. Let's go ahead and get started with 16 here. A car with a velocity of 22 meters per second. So that would be the car's initial velocity. Is accelerated at the rate of 1.6 meters per second squared. So that would be A. For 6.8 seconds. And that's t. What is its final velocity? And that, of course, would be vf. So I recommend when solving physics problems that you do read the problem once through, and then a second time highlight the pertinent information, and either become an underlined person, as I've demonstrated in this question, and I'll do 17 with an alternate way of listing the information. So either be an underlined person or be a list person so that you identify the key information provided in the question. The reason for doing this is to make it obvious what information you're provided with, what you're trying to find, so that now as you go to the reference table, you can usually correctly identify the equation that you would use to solve the problem. So we have, in this problem, given VI, A, and T, and we're looking for VF. On the reference table, the one that pops out is VF equals VI plus AT. So we start by writing down the equation. We now go ahead and we substitute with units. Our value of VI is 22 meters per second. Our value of the acceleration is 1.6 meters per second squared. And our value of t is 6.8 seconds. Okay? We can see that the seconds from the time cancels out the square in the acceleration denominator, the units of meters per second squared. And so we end up with just meters per second plus meters per second, which makes sense to us because our final answer is a velocity which should be in meters per second. Not going to show the cancellation of those units all the time, but I thought since we're just getting started here that would be a good idea. All right, so we go ahead and we do the algebra and the math. Pause this video, take whatever steps are necessary for you to be successful. And when done, you should get an answer to 2 digits because all our given information is measured to 2 digits. We should get an answer that is 33 meters per second. And there's your answer to number 16. Okay? Moving on to number 17. Says determine the final velocity. So they want us to find VF. I said it for you, I would demonstrate the list way of doing this, so I'm going to start over here. Okay, so final velocity of a proton that has an initial velocity 2.35 times 10 to the 5th meters per second, and then is accelerated uniformly in an electric field at the rate, they give us the value, negative 1.10 times 10 to the 12th meters per second squared for 1.50 times 10 to the negative 7 seconds. Clearly that's the time. 1.50 times 10 to the negative 7 seconds. So this event took place in a very short amount of time. And you also notice that the acceleration is negative, so we can also deduce here that the proton is being slowed down. Okay? So once again, we go ahead and take a look at our given variables, what we're asked to find. We now go to the reference table. And again, our choice would be VF equals VI plus AT. So we start with that equation. We now substitute with units. VF, our VI value is 2.35 times 10 to the 5th meters per second plus our given A value, negative 1.10 times 10 to the 12th meters per second squared, and our time 1.50 times 10 to the negative 7 seconds. We go ahead and we do the calculation. Again, pause the video if you need time. And when you're done, our answer should be the 3 digits. All our given information was measured to 3 digits. We should get 7.00 times 10 to the 4th meters per second. I would encourage you to ask any questions you have when we get to class tomorrow. If you didn't understand how to do either one of these problems before we go ahead and we tackle number 18 and 19 in class.